Perfect. So I'll start. Hi, everyone, and thank you very much for joining. If if you're just starting your day, I hope you have a great day. And if it's like me already towards the end of the day, then hope you had a great one. I'm Yair Zarka. I'm a product manager on the Defender for IoT team, and we're here today to discuss the cloud capabilities and the advantages of the Defender for IoT solution. In general, on today's agenda, we'll be discussing the cloud connectivity advantages, different connectivity methods for connecting the OT sensor to the cloud, and a deployment path for customers newly deploying to the cloud. Now, if you'd go maybe 5 years ago or a bit more than that, the concept of connecting your factory or your OT environment to the cloud was relatively new. But I think that today, we are starting to understand that cloud is the new standard in manufacturing as well, be it the different cloud providers or also the automation vendors such as Rockwell or Siemens or ABB, who have all created and are providing a cloud connected solution for their manufacturing environment. Now, this is done to drive business efficiency, to improve security, and for many other reasons. But we are understanding that regardless of what the status is, what the status used to be regarding connectivity, the new standard is a cloud connected standard, and we have to meet the threats where they will meet us. Now, in general, the way we see the cloud management advantages is that the cloud management is secure by design. We are able to enhance the security value offered to our customers in a way that is not possible with an air-gapped security solution. We are always up to date. The cloud portions of our solution are updated instantly, and it also lowers the costs for the customers. And I'll dive into all of these points today. I'll start with the security value, and this is an overview, and we'll go into each of these into with some more depth in the next few slides. But in general, attackers are constantly evolving. They're using short-lived DNSs, and they're also using the cloud. And to be able to protect and to beat them at their game, we have to offer real-time threat intelligence updates, and that's something that we can do when we're cloud connected. So the same goes for vulnerabilities. It's true that you won't be always able to update an OT environment to the latest firmware version, and that some vulnerabilities will always exist. But for those critical vulnerabilities that you need to update or you want to be aware of, there's a criticality for how quickly the system is aware of these new vulnerabilities. And with the cloud, that's something that can happen much faster. Being cloud connected also allows us to monitor behavioral anomalies and compare them to standard activity, not only across one sensor, but across all of the other behavioral databases that we have across Microsoft. And it allows us to correlate to more data sources and known standards. Now, if we discuss the threat intelligence part, Microsoft is constantly collecting and building a threat intelligence package, a threat intelligence database. It's not one data point, it's trillions of signals collected daily. Microsoft collects these security signals from Office, from Windows, from Defender for Endpoint, from Defender for Cloud. We at the Defender for IoT have a research team called Section 52 that is doing dedicated IoT and OT security research. And all of this together allows us to offer our customers a real-time IoT and OT threat intelligence package that is not only updated, on a yearly basis or based off open source or just vendors selling the threat intelligence data. This is Microsoft. This is the data collected by all of Microsoft, served directly, instantly to our customers, ensuring that they receive the latest threat intelligence and are able to counter the attackers as they evolve and grow. For vulnerabilities, we're also monitoring and are integrated both with all of the vendors and with NIST and the different and the vulnerability databases, and these are uploaded and updated in the Cloud Manager constantly. So once we detect in our OT solution the firmware or the model of a certain device, the vulnerability is matched to it immediately. And this is also the case with Windows CVEs or other CVEs or other vulnerabilities in your environment. Now, another important security value is the value we can bring based on network connections. Each device communicating in your network has a certain fingerprint that the OT sensor or the enterprise OT sensor can record and analyze. And once this information, once these connections can be correlated to different information that we can infuse in the Cloud Manager, we can ensure that you have the best possible visibility into where your devices are communicating with. Are these destinations or DNS connectivities or DNS requests okay, or are they dangerous? Are they malicious? We can ensure that that your communications are as you expect them to be. Do you have cross-subnet communication that shouldn't be taking place? Do you have communication to the open internet that shouldn't be taking place? And this is security value that can be driven based on the network connections in the cloud. In addition, we understand that in the OT context, an interesting pivot of the data is at the site level. Now, not only being able to understand, okay, this manufacturing site that I have in New Jersey has 2 sensors and I want to see all the alerts and inventory for those sites. It's more than that. It's correlating the OT sensor traffic and the OT sensor data to other data that is correlated to that site. So it could be Azure Active Directory, it could be Defender for Endpoint, and all of these can be correlated at the site level to offer insights into the site posture, into the risks that this site faces. And lastly, in this section is the correlation to the MITRE ATT&CK framework. Now we understand that most organizations have one strong trained SOC that is working both the IT and the OT security risks, and to be able to allow the same SOC to understand these OT risks and OT threats, we've mapped in the cloud platform all of our alerts to the MITRE ATT&CK framework, making sure that if a SOC analyst sees a PLC stop command alert, they know where in the MITRE ATT&CK framework it meets their risk analysis. Okay. Now regarding lowering the total cost of ownership. In general, it's cheaper and easier to do things at scale in the cloud than it many times is possible to do locally. Now we've added a possibility to do a single place for role-based access with out-of-the-box roles and permissions, so you don't have to invest a lot of time and effort into creating role-based access policies for your OT solution. And we offer granular permissions based on sites, subscriptions, and roles. In addition, there's one management console for all the sensors and the security monitoring, so you don't have to have multiple experts that know how to work with different systems. It's all managed in one central console. Cloud updates are, and I'll go into depth about them in a second, but cloud updates allow you to update. I know we have customers with hundreds of sensors, so just with a few clicks, without having to contact the site, without having to be in touch with the maintenance teams on the different sites, you can update this directly from the cloud. We can monitor the health of the sensors centrally as well and troubleshoot in advance and be proactive about the health monitoring of our sensors. And you can also configure templates for the different sensors and manage them at scale. And in general, we're investing a lot into both configurability, updatability, and visibility of the sensor deployment status, all available in the Cloud Console. Now, regarding keeping the solution up to date, I'll go over a few of our latest offerings and how we can ensure that they are always up to date in the cloud, be it recommendations, health monitoring, or other features. Now, the first feature I'll discuss today is the OT recommendations available in the cloud. We aim to have actionable recommendations, and for this example, this is literally a turn of a switch issue where PLCs are in an insecure operating mode and are open to attack. And we are always adding more and more recommendations to the Cloud Manager based on all of the data we see coming in at scale and anonymously from the customers, and we can understand what would be impactful and what is both impactful and actionable for our customers. Regarding health monitoring, so this is an example with 4 different sensors, but as I said, we have customers with hundreds of sensors. Now, we have customers on the one hand who are not yet cloud connected and managing the health status manually. And on the other hand, we have customers who are already connected to the cloud and they have the possibility to just monitor from a central location, create alerts based on the health and the connectivity of specific sensors. You can make sure that you're receiving that if a sensor, for example, is disconnected from the network or an interface is disconnected on a specific sensor, you could receive an alert and it could be sent to the relevant operations team to make sure that we are constantly receiving the maximum security protection from the solution. Regarding remote update, so this is also a possibility that we have, and I mentioned earlier, it's to, with 2 clicks, choose a sensor and update it. We've split the update process into 2, so one part for uploading the file to the sensor itself, and another for installing the new update. And you can, what we are hearing, and a lot of the feedback we have from our customers is that they would like to do one of the things overnight, or when there's and then update it when there's a maintenance window or downtime at the site. Now I'll continue with the sensor settings. So sensor settings allows us to create templates and then manage sensors at scale, all from the cloud portal. So for example, if you want to limit the bandwidth for a specific sensor, you can do it at a site level, at a zone level, and and reuse these templates across the different sites and zones, ensuring that the maintenance and the overhead of deploying the security solution is as low as possible. Now, in general, our goal in working with the Azure infrastructure, as I said earlier, is to do more with less. And there are many Azure features that are available out of the box and that can be built upon. So for an example is the role-based access, which leverages Azure Active Directory. If you already have Azure Active Directory groups in place, you can assign roles to Defender for IoT by site or by subscription. You can automate many of the actions in Defender for IoT with logic apps. This can be alerting on health status of sensors, or it can be exporting the device inventory on a daily basis to a data lake, as some of our customers are doing. It's possible to create dashboards and reports with the Azure workbooks, and to audit the activity in the portal with the Azure activity log, if that is a regulatory requirement. Now, one of the main questions that comes up with the cloud connectivity from the OT sensor is how secure is it? What security principles did we build into it? I think the two main security tenets for our solution, for the OT cloud connected solution, is that the sensor is the one. On the one hand, there are only outbound connections from the sensor to Azure, and that all data is encrypted in transit, which means that on the firewall, you only have to open outbound rules. The sensor is the one initiating all connections. So even for a remote update, that sensor will check with the cloud every so often. And once it receives a message that it's ready to update, we'll pull the package to the sensor. And everything's encrypted with the highest levels of encryption, ensuring that your data is private on its way between the sensor and Azure. We support a few different connectivity models, and these are all tested, documented, and in production use by our customers across the world. So one option is to connect through an on-premises proxy. Another option is to connect to your sensors through a proxy residing in Azure. And if you have an express route deployment, this is many times what we would offer. And another possibility is to connect your sensor directly via the internet. And this is possible to do in a secure way. As I said earlier, the connection is encrypted. Now, there's no right connectivity model or more secure connectivity model. There are different connectivity models depending on your use case. And we actually have customers with using all the 3 different connectivity models for different sites. So if there's a site that already has ExpressRoute in place, they might use that connectivity model. And then for a small site with a few devices on it that they're monitoring remotely, they might connect directly via the internet. So these are all different possibilities. Now, if we're looking at the different steps in our cloud deployment process, our recommendation is just to start with a pilot, choose a specific site, set up the connectivity, activate the different sensors, and connect to your SIEM SOC solution. Now, if this is in Sentinel, it's in the cloud, and if you have an on-prem or another third-party SIEM, that's also something you can connect to. And once this pilot has been concluded successfully, expand to all the different sites and ensure that you're enjoying secure, safe, up-to-date connectivity. Now, a lot of many times the discussion around cloud returns to what are the costs incurred with the cloud connectivity. Now, here I'm comparing to Defender for IoT's pricing solution. So in general, the pricing is the same. We don't charge additional costs for cloud licenses. It's the same license, activation license for the Defender for IoT sensor. There are no additional costs for direct connectivity from the sensor all the way to Azure. And if you're using Sentinel, there are no additional costs for alert ingestion and inventory ingestion in Sentinel, which is also a big plus for this. Now, I'm approaching the end here and we'll have time for Q&A. Yeah. So Adi, Jason, if there are any questions from the crowd, I'll be happy to answer.
Yeah, Adi, is there any specific ones we should be calling out?
Let's do whatever we didn't manage to still answer on the chat.
Okay. So the first question is, when an OT network has accounts from a separate, isolated domain, how do those accounts get correlated with corporate user accounts in the Azure AD domain?
Could you repeat the beginning?
Yeah. When an OT network has accounts from a separate, isolated domain, how do those accounts get correlated with corporate user accounts in the Azure AD domain?
That depends on the deployment, but in general, if you have the possibility to export the accounts from the local domain to Azure, we can ingest them and create workbooks and join them on together in the workbook and correlate them by mail or by user ID if that's a case that is relevant.
Great, thank you. The next one we have is, how does Defender for IoT align with Zero Trust framework?
So I think one of the major advantages of using a network sensor is that you're able to see what devices are communicating with what devices, and then easily see what subnets are communicating with what subnets, what VLANs are communicating with what VLANs, and ensure that your Zero Trust policies are actually correct and enforced, and easily see where you should invest in segregation on the one hand, and on the other hand, where your policies are working.
Great, thank you. The next one is a bit long. It is, if you have an express route, it is suggested to leverage an Azure proxy. We don't fully understand why a proxy is still required if you're able to route the traffic already to Azure. Can't you route to a private endpoint within your environment?
Okay, that's a great question. The way I'll ask Adi if she can maybe also share in the chat the specific documentation for this. But in general, the express route connectivity allows us to transfer the data from the OT environment to the cloud. In Azure, we need to ensure that the data reaches Defender for IoT, and for that, there is a need for a proxy in the Azure VNet. But it is possible to configure a private endpoint that the sensor connects to. That private endpoint would be a private endpoint in the Azure VNet. And from that private endpoint to the Defender for IoT backbone, we'd use a proxy.
Great. I'll just give it a few more seconds to see if there are any questions that come in the pipeline. But if not, those are all we have. So I'll just give it a minute. We have a new question. It is, what are the capacity limits for the sensors?
I'm going to assume the question is about traffic throughput. We have different sensors validated for different throughputs. So it really depends on what hardware you provide. And we are installed in multi-gigabit core switches. And the sensor has a proprietary DPI framework that deals with all of this traffic coming in. But yeah, and I'll say multi-gigabit networks.
I will share the link for the documentation that describes it in the chat.
Thank you, Adi.
Great. We did have one that just came in. It is, how does Defender for IoT, how can it be helpful for an SMB?
I think first of all, it's important. The realization is important that SMBs are also facing these security threats. Anyone with even 2-3 manufacturing devices, that's probably the most critical part of their business. If they have an OT environment, it could be, I don't know, a small shop with a few modern automation devices that they want to protect. The Defender for IoT sensor can be installed both virtually and with a physical appliance and directly monitor the communication, this machine-to-machine communication. And I think the threat is real both for SMBs, and also this solution can monitor, alert at relatively very low costs on OT issues, on OT security threats, and help SMBs adhere to the highest security standards.
Great, thank you. It seems that's all the questions we have for today. So I'd like to thank you, Yair, for being our guest today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We'd love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you, and see you next time. Goodbye.